variant 1. First question. The diagram shows the apparatus used to electrolyze dilute sulfuric acid. He's pointing to the electrodes and he's asking platinum what? These are platinum electrodes. So the first question, platinum electrodes. You always point to the end of the wire. This is not the electrode. This is not the electrode. These are the electrodes. Okay, at the end of the wire. B, give one observation made during this electrolysis. Dilute sulfuric acid means that we have hydrogen ions, we have sulfate ions, we have hydrogen ions and OH ions. Both of these come from water, okay? Type. What will be produced at the cathode? Hydrogen ions will discharge at the cathode as hydrogen gas. While at the anode, OH ions will go and produce water plus oxygen gas, which means, you know, a sure observation is that we will see bubbles or fizz or effervescence at any of the electrodes. So the observation is bubbles, fizz, or effervescence. CI, it's a very important question. Compare the volumes of oxygen and hydrogen produced. Okay, when you look at the diagram, you can observe easily that hydrogen is more than oxygen. And if you said in the answer, hydrogen is more than oxygen, if you said in CI, hydrogen is more than oxygen, you take 1 mark, not 2. So why is this question worth 2 marks? ركز معايا. H positive or OH negative are discharged. LH is discharged at the cathode, LOH is discharged at the anode. H or OH both come from water. In water, the ratio of hydrogen to oxygen is 2:1. So when water is discharged, it will always produce twice the amount of the volume of hydrogen than oxygen. Okay, twice as much hydrogen than oxygen. Hydrogen is always twice the oxygen because in water, the ratio of hydrogen to oxygen is 2:1. Double I, which substance breaks down to form these gases? Water. H will OH come from water. Okay? H will OH اللي عملوا لي السؤال اللي فات come from water. Give one test to distinguish between hydrogen and oxygen. Like, when we think about this question, we either have a test for oxygen or a test for hydrogen. How can we distinguish between both? If you do the test of oxygen, it will give a positive result with oxygen and will not give a result with hydrogen. If you do the test for hydrogen, it will give a positive result with hydrogen and not give a result with oxygen. So you either say a lighted splint, which is the test for hydrogen, no effect with oxygen, pop sound with hydrogen, or you say a glowing splint, which is the test for oxygen, it relights مع oxygen and no effect with hydrogen. Both are correct, okay? Either you choose to go in the way of lighted splint or glowing splint. Okay, question 2 is investigated. What happened when dilute nitric acid reacted with aqueous solution of 2 different alkalis, solution N and solution O, okay? 2 different alkalis, take care, N and O. It's not the same alkali with different concentration, they are 2 different alkalis من الأول أصلا. وبعدين in an experiment that involves reacting alkalis with acids, يعني titration mainly, أو light titration, he's using a measuring cylinder. دي على طول inaccuracy. Okay, this is an inaccuracy. You don't use measuring cylinder in experiments where you need to get accurate results. So he is using a measuring cylinder. This is the first inaccuracy. Second, he uses a polystyrene cup. We need to know carefully what is polystyrene. Polystyrene is a substance that's a very good heat insulator. It minimizes heat loss to the surrounding. Okay, this experiment, I suppose you've read it. In a measuring cylinder, using a measuring cylinder, he added a 50 centimeter cube of solution N, which is the first alkali, and then he recorded the initial temperature. He filled a burette to the 0.0 mark with nitric acid, and then he started adding 5 centimeter cube of nitric acid and measuring the temperature until he reached the maximum temperature. وبعد كده he started measuring the solution every 5 centimeter cube until he reached a total of 40 centimeter cube. The next page, he's asking you to take the readings. I'll leave it for a second كده to check. These are the readings. Okay. And then this is the graph. I tried to do it as accurate as possible, يعني. This is the graph. The labeling is for a mark, experiment 1 and experiment 2, and the plotting is for 3 marks. Each incorrect plot deduct a mark على طول. طيب. Use your graph to estimate the maximum temperature of the solution when 13 centimeter cube of nitric acid were added to 50 centimeter cube of solution N. He's saying he needs to know the temperature, the maximum temperature, when 13 centimeter cube of nitric acid were added. So you will come at 13 centimeter cube, and he needs you to show how you worked out your answer. You will raise the line until you hit experiment 1, and then you will read the y-axis, okay? It will be around 27 degrees, yani plus or minus 0.5 degrees Celsius is accepted. Okay, this showing on the grid is for a mark, and the value 27 plus or minus 0.5 degrees Celsius is for a second mark. You must show these two perpendicular lines, okay? Name an indicator that could be used in experiment 1. Actually, most of the indicators are accepted. Phenol, phthalene, litmus, or methyl orange. Choose one that you know its color changes carefully, okay? Type. Solution N and solution O are the same concentration. In which experiment is the temperature change greater? Suggest why. Okay, he did the same experiment twice. Once with solution N and the other with solution called O instead of N. And then he watched the graph, and he's asking you which solution caused the greater temperature change. I think it's obvious from the graph that the greater temperature change was in experiment 1 or with solution N. What's the reason? If he's adding if he's adding the same acid, nitric acid, the same concentration, the same everything, this acid is identical to a solution called N and a solution called O of different alkalis, okay? And we know in a neutralization reaction that will take place is exothermic. Why is the temperature change larger in this beaker? The only reason is that solution N is a stronger alkali. Why did it make a more vigorous reaction and a higher temperature change? It's a stronger alkali. Solution N, sorry, it's a stronger alkali. Okay, or it has a higher pH. Higher pH, it's a stronger alkali, but it's another way of saying it's a stronger alkali. G, how would the results differ if in experiment 1 if 100 centimeter cube of solution N was used? Take care he didn't increase the concentration or the strength of the alkali, he just increased the volume type. Since we're measuring temperature change, take care. When you increase the volume, temperature changes decrease. When you increase the volume, temperature changes decrease. Yani, this means if I got 100 centimeter cube of N instead of 50 centimeter cube, and I'm adding the acid, take care. Here, the heat produced from the reaction will have to distribute itself over 100 centimeter cube of the alkali, which means the volume for the heat to be distributed is larger, so the temperature change will be lower, okay? Temperature changes would be smaller. Suggest H. Suggest why a polystyrene cup is used in this experiment and not a copper can. Whenever he's asking why a polystyrene cup is used, the answer is the same. Polystyrene is an insulator, a heat insulator. While copper, since it's a metal, it's a very good conductor of heat. Okay? State one source of error in this experiment and suggest an improvement to reduce this source. Heat loss to the surrounding. حتى even when he's using polystyrene ممكن يحصل heat loss to the surrounding. The improvement is to insulate the whole apparatus. Okay, insulate and you add the whole apparatus in some sort of insulation from heat. The better answer in my opinion is using a measuring cylinder is a very common source of error, and the improvement is use a burette or a pipette. Stick with burette better. Okay, so this is the source of error. P is an aluminium, have aluminum and iron. Solid P was divided into 3 portions. The first portion of solid P was heated. Condensation formed at the side of the tube. When you heat a solid and then you find condensed droplets at the side of the tube, this means that water was present or that solid P was hydrated. Okay. Test 2. a flame test is carried out on the second portion of solid P. Flame test, حلو قوي. Flame test on an aluminium salt. We took a flame test for sodium, which was yellow, for potassium, which was lilac, for lithium, which was red, for magnesium, which was white blinding. We didn't take a flame test for aluminium. So observation, no color or no change. No color or no change. Even if you said the aluminium will glow, it's correct, but there is no flame color. Okay? Test on solution of P. Distilled water was added to solid P in a test tube and shaken to dissolve. The solution was divided into 4 equal portions in 4 test tubes. The following tests were carried out. Test 3, he added several drops of aqueous sodium hydroxide, okay, to the first portion of the solution. Then excess aqueous sodium hydroxide was added to the mixture. I have aluminium as the cation. Remember, aluminium gives me white precipitate soluble in excess or dissolves in excess. White mark, precipitate a mark, soluble or dissolves the third mark. Test 4, several drops of aqueous ammonia were added. The same test is repeated for aluminium, the cation, but with ammonia. With ammonia, aluminium gives white precipitate, insoluble in excess. White for a 1 mark, insoluble in excess for the other. You take the mark for precipitate only the first time you say it in the exam. After that, you doesn't give you the mark. White precipitate, insoluble in excess. Okay. 2 further tests were carried out and the following observation made. Dilute nitric acid followed by silver nitrate solution. This is a test for halides. Remember? Chloride, bromide, and iodide, white, creamy, yellow, PPT. No visible reaction, so I deduce that there are no halides present. Test 6. He added nitric acid and then aqueous barium nitrate. Barium was a test for sulfate. Barium nitrate was a test for sulfate. White PPT is a positive result, so I have sulfate. What does test I have sulfate. What does test 5 tell you about solid P? It's not a halide. There are no halides present, okay? Since it gave me a negative result. Identify solid P. I know it's aluminium. From the question, it's a given. And I now know from this test that it's a sulfate. So the solid is aluminium sulfate. Describe the appearance of solid P. How would I know the appearance? We agreed that group 1, 2, and 3 and zinc compounds are white. So this is aluminium from a group 3. It's a group 3 element, so it must be white in color. Last question, which was not an easy one, so please focus with me. Agri-limes are mixtures of calcium carbonate and calcium oxide. Okay, there's something called agri-lime, which is a mixture of calcium oxide and calcium carbonate. Farmers use agri-limes in fields to neutralize acidity. So they add this thing called agri-lime to neutralize the acid. Plan an investigation to find out which 2 different agri-limes, Q or R, will neutralize more acid. You're provided with a common laboratory apparatus and chemicals, including dilute nitric acid. So he stated the acid you should use, nitric acid. He gave you 2 samples of agri-lime, one called Q, one called R, and he needs to know how much, which one of the 2 different agri-limes will neutralize more acid. The more agri-lime, the more the agri-lime neutralizes more acid, it's the better. Okay. So how would we solve this? There are 2 ways actually. Number 1, you get a known mass of the first agri-lime Q. We will do the whole experiment planning on Q, and then we will repeat it with R at the end. But don't say get 2 samples of agri-lime at 2 portions of acid. No, you just work on one. Add a known mass of agri-lime Q to 25 centimeter cube of nitric acid. So he got a beaker with nitric acid, 25 centimeter cube nitric acid, and he started adding agri-lime Q, and he knows the mass he's adding from. Okay, containing methyl orange indicator. Here he put methyl orange indicator or any indicator you'd like. Just know the color change in the acid. Okay, he will keep adding the agri-lime till the indicator turns orange, which means إنه خلاص the indicator طبعا was red since it's added to an acid, and it turns orange, which means إنه the acid was neutralized. Record the mass of agri-lime added. يعني he's still adding لحد ما حصل neutralization to all the acid, and then he's recording the mass needed. Okay, from the agri-lime to neutralize the acid. Then he repeats the same experiment with agri-lime R. The experiment that needs less amount of agri-lime is better. يعني كأنه بيقول إنه if you have 2 samples of agri-lime, Q and R, and you needed a lower mass from Q to neutralize the acid, يبقى Q is better. Okay, لأنه Q in this case did the same job that R did, but with a fewer mass. Oh, sorry, with a lighter mass. This is one way of solving the experiment. Okay, طيب. Another way, you don't have to get the acid and start adding agrelime Q to it. He reversed the process. He got a known mass of agrelime Q and started adding the acid gradually from a burette with an indicator in the acid. You cannot add an indicator to a solid. So he added the indicator in the acid. So he got the beaker, he got agrelime Q, and he started adding the acid with indicator in the acid. Okay. Neutralization takes place as soon as the acid hits the agrelime and reacts with it. He starts adding the acid until the indicator in the acid turns orange in the beaker, which means that all the agrelime is neutralized. He records the volume used of the acid and then repeats the same experiment. With R, if one of the agrelimes consumed a larger volume of acid, it means that it is a stronger one, or that it's more concentrated, or that it neutralizes a larger volume of acid. So the experiment using the larger volume of acid is better. Those are the two ways to solve the experiment. Each point that I write is worth 1 mark. Okay, so check for yourself. And we have finished the exam. This was November 2016, variant 1 by Mr. Marco.